Online opinions have become a goldmine of information for businesses. They convey valuable marketing hints about products and services and help identify new opportunities. What if we could gain valuable insights from a multitude of opinions? The value could be huge. We are Team F. We used data mining tools to explore and understand sentiments in online reviews. The structure of our project is as follows. Firstly, we are going to discuss the main goals of our project. Secondly, a brief overview of the dataset. Further, we are going to discuss the methods that we used and the results that we obtained. Finally, some conclusions that we can draw based on the results. The goals of the project are as follows. Firstly, to predict customer recommendation based on the test review. Secondly, extract informative features from reviews. Finally, to draw some business insights for the products. We were given 12,000 text reviews, of which 6,000 reviews correspond to camera class. Further, the attributes that we had for each entry are label, which states the customer recommendation, product model number, rating of the product, and finally the customer text review. The text reviews were used to predict recommendation based on the text. We tokenized the text reviews and created bag of words. Subsequently, we trained the classifier in a cross-validation loop to obtain the results. We used 3 types of classifiers to predict customer recommendation, namely, naive Bayes, support vector machines with radial basis function kernel, and random forest. It can be observed that naive Bayes misclassified most of the reviews with label no. We cannot afford to misclassify a major portion of the reviews with label no, because some critical reviews contain some of the most crucial flaws of a product. Further, it can be observed that the support vector machine classifier did a better job at predicting the no labels in the reviews. However, it still had a high false positive rate. Finally, these are the results for the random forest classifier. As you can see, it performed far better than the other 2 classifiers at identifying the no labels in the reviews. So we selected this classifier to predict customer recommendations. In order to identify the important features in the text, we split the data into 2 chunks, tokenized them separately, and trained a naive Bayes classifier to predict probability of occurrence of the particular word in the reviews. Finally, we used chi-squared test to identify most informative features. We used the trained naive Bayes classifier to identify features associated with the Fuji camera models that were performing well, with an average rating greater than 4.5. These were some of the informative features identified by the classifier. Further, these were the features associated with the Fuji camera models that were performing poorly with an average rating less than 4.0. These were some of the words that customers used to describe those models. Customer opinions are subjective. They are usually a mixture of negative sentiments as well as positive sentiments. This could result in misclassification of data and also lead less efficient feature identification. Prediction of a binary output from a large set of attributes makes our results narrow. Using classifiers to condense textual opinions to either a yes or a no could result in loss of information since customer opinions need not necessarily fall into
Created using Powtoon.